Okay, before we start the lesson, I want to go over some things. In the following lessons, we will be trying to describe the graph of a function without a graphing calculator. When I say that, I'm not meaning you can't look at it with a graphing calculator, but what I'm trying to say is that the methods you will be using, you will be showing your work as if you didn't have a graphing calculator. We will want to find the zeros only using the equations as a guide and not by using our calculator. So you will have methods to use the equation. When we're talking about a zero, we're talking about where it crosses the x-axis. We will be finding out some other things, and those things will be, how many zeros are there? How many positives will there be? And how many negatives will there be? Let's get started. We're going to be doing division. We're going to be getting some remainders with these polynomials also. We're on section 6.5 and this is week 16. Let's just do an overview. In this last several lessons, you have added polynomials and subtracted and multiplied, and today we will be doing division. Now, you have been factoring, and this has a similarity to division, but it's not really division. We will be doing what you've learned about with long division. We'll be doing that with polynomials today. So let's just review what it would be like to do division, so we can just get an idea of what it was like with numbers, so we can do this with letters. So what we did is we took this number here and we said, does 4 go into 2? No, but it goes into 25. So 4 times what is close to 25? And that was 6. We got 24. We did that by multiplying these two, and then we subtracted. 25 minus 24 is 1. Then we bring down that 6, and we ask the same question. 4 times what is 16? It is 4 exactly. We multiply those two and get 16. Subtract, we get 0. Bring down the 5. 4 times what gives you 5? 1. And 4 times 1 is 4. Subtract, get 1. We do our remainder. And now we need to see what do we do with that remainder? Depending on what grade you were in, sometimes you wrote a remainder 1. Other times you wrote it as a fraction, and that is exactly what we're going to do today. We're going to write this as a fraction. We're going to take the 1 over the 4. Let's do this now as a polynomial. All right, we're going to do long division, and this is done just the same as the long division with numbers that we just reviewed. So if I have this equation right here, we're going to do this one, and the one that's in the back goes on the outside, and this goes on the inside. So here we go. We're going to start out. We have this here. I want you to notice, though, we have a 4th degree, a 3rd degree, but no squared. No x squared at all. We're going to have to put in a place value for that, just like we did with our synthetic substitution. So this is what it will look like. We have our place value here for the x squared. So we're going to ask ourselves 4x to the 4th times, we're going to try to get that by multiplying something by x squared. So x squared times what gives you 4x to the 4th? That'll be 4x squared. Then we multiply. We multiply that 4x squared by both the 1 and the x squared. And we get 4x to the 4th and 4x squared. I want you to notice, though, we put the 4x squared under here so they'd be like terms. We're going to subtract, and when we subtract, that will be subtracting on both of them. Don't forget that. When that happens, this right here will cancel, and these will be add together with that subtract there. So in a sense, we're subtracting. And we're going to bring this down. We also brought down the 2x over there. Now we're going to ask ourselves, x squared times what gives us 3x to the third? That will be 3x. So when we multiply that 3x to everything, that 3x will be multiplied here and there. We will get 3x to the third, and we're writing that 3x right under the 2x because they're like terms. We will be subtracting. I will subtract both of them. My 3x cubes will reduce or cancel out, and we'll bring down that negative 4x squared and the 1x, and we'll bring down that 1 right here also. Then we'll ask ourselves the question, x squared times what gives us negative 4x squared? It will be negative 4. When we multiply the negative 4 to both the x squared and the 1, we will get negative 4x squared minus 4. We will change the signs because we're going to be subtracting. My negative 4x squared and 4x cancel. My 1 and 4 become 5. And my remainder is negative x plus 5. I will write that remainder as a fraction. I will put the negative x plus 5 on the top and the x squared plus 1 on the bottom, or the denominator. And my answer will be right here. Let's do some together. I hope you were just watching this one because we're going to do one together. Let's do number 1. Before we even start, do we need to fill in any zeros? So I have a squared to the first power and then to the none, so we do not need to add any zeros. We have this here, and I'm going to have an n times what gives me 2n squared. It'll be just 2n. Multiply these to each other. I will get 2n squared plus 4n. I will be subtracting, so I'm going to subtract both of them. This will cancel, and I'll be left with negative 17n minus 19. I'll ask myself, n times what gives me negative 17n, and that is negative 17. Multiply these together. I'll get 17n minus 34. I will make both of those, I'll change the signs of both of those. These will cancel, and I'll be left with positive 15. And I'll write that as a fraction. 15 over n plus 2. Let's do number 2. We're going to check to see if we need to put any zero place values. I have a 3, 2, 1, then none. So we don't need to put any spacers in there. Q times what gives me negative 4q cubed? That will be 4, negative 4q squared. Multiplying that out, I'll get negative 4q cubed minus 28q squared. Change the sign. These will cancel. I'll get these two added together will be 14q squared. Bring down my 4q. Q times what gives me 14q squared? That will be 14q. Multiply it out. We'll get positive 14q squared plus 7 times 14, 98q. we're going to change the sign. These will cancel. 98, positive 90, positive 4 and negative 98 is going to be a negative 94Q. I'm running out of space. Let's see if I can squeeze some more in here. Q times what gives me negative 94? Q would be negative 94. Multiply that out. Here and here. We're going to have negative 94Q minus 94 times 7 is like 658. We didn't bring our plus 5 down there. Let's bring our plus 5. We're going to change the sign. And so we'll have 663 as a remainder. So we'll write plus 663 all over Q plus 7. All right, let's do number 3. If you notice, number 3 there needs to have a spacer. So let's put the spacer in, and I'm going to scoot up a little so I have room. We have z plus 2. We're going to put the spacer in. We'll have negative 3z squared plus 0z minus 14. We ask ourselves, z times what gives us negative 3z squared? It'll be negative 3z. So we multiply those out right here, and we'll get negative 3z squared plus or minus 6z. Change the signs. That goes away. This will become 6z minus 14. Z times what gives us 6z? That's just 6. Multiply that out, and we get 6z plus 12. Let's change the signs. These will cancel out, and I will get negative 26. So my remainder is negative 26, and I will put that all on as the fraction z plus 2. Right now, we're going to talk about synthetic division. As you notice, that long division is, as it always has been, is just long. There's got to be a better way. Synthetic division is it. And so this is a shorter way to do long division, but it only works with binomials. And it only works for binomials in this form. X minus r, or some number that represents r. And so that's what we're going to be doing for a while here. Let's do this first one. I want you to just watch. Don't worry about doing it. Just watch. All right. We're going to divide this 5th degree polynomial by the binomial. We're going to do that using synthetic division. What we're going to do is we're going to take that x plus 4 and we're going to put it out on the outside. When we do that, we're going to set that x plus 4 equal to 0 and find the 0. So x plus 4 equals 0. We're going to solve by subtracting, and we'll have x equals negative 4. So we're going to put a negative 4 on the outside over there. Then we're going to take all the coefficients out front here. Do we need any zero spacers? No, we don't need to put any spacers, so we're just going to put in the coefficients. Negative 5, negative 21, negative 3, 4, 2, and 2. And then we start our synthetic division. Bring down our negative 5, multiply. 4 times negative 5 is 20. Add, we get negative 1. Multiply the negative 4 times the negative 1, we get 4. Add, we get 1. Multiply the negative 4 times the 1, we get negative 4. Add, we get 0. Multiply the negative 4 and the 0, we get 0. Multiply, should be add, we get 2. Multiply the negative 4 and the 2, and we get 8, or excuse me, negative 8. Add, we get negative 6. Now, we're not finished, because we need to have a polynomial and a remainder. The remainder is the negative 6 right here. This is the polynomial. We write that as the coefficients. That's the numbers in front of the variables. We started off with x to the 5th. We've done it 1 down, and so we're at x to the 4th. So this will be negative 5x to the 4th, negative 1x to the 3rd, x squared, 0x, we won't write that, plus 2, and then we'll have a remainder of this. Here is our answer. We took those coefficients from right here. We went 1 degree down from where we were. We were at 4. So we were at 5, and now we went down to 4, and then we just followed suit after that. And here was our remainder, and we put that over the top of what we had before. All right, let's do some examples now. We're going to divide these with synthetic division. We're going to take this one right here, and it's going to go in the box, and this will go on the outside of the box. So if you remember, we set this equal to 0, then we added subtracted the 1 over there, so we're going to have a negative 1 right there. And my coefficients here are going to be 1, 11, 9, and negative 4, but we do need to check if we need to put any spacers in here. This has a third power, second power, first power, so it goes 3, 2, 1, none. Okay, so we don't have to put any spacers in there. So we have 1, 11, 9, and negative 4. Bring down our 1 and multiply. Multiply, we get negative 1. Add, we get 10. Multiply, we get negative 10. Add, we get negative 1. Multiply, we get 1. Add, we get negative 3. We're not done. We still have to write the answer. So the answer comes with this as my quotient or the answer, and this is going to be the remainder. So here's my coefficient. It's 1. 1m to the, we take a 1 down from there, from 3 down to 2, so we say 1m squared. We don't have to write the 1. Plus, here's a 10, and we just go down 1 from there. That was a 2, now it's a 1. M to the 1, or just m, and then minus 1. Then here's our remainder. We write that as a fraction, negative 3 over m plus 1. We put a little plus for it, and that's our answer. Let's do number 8. Number 8's really cool because we're going to actually be able to make this smaller. I want you to notice every one of those we can divide by something. And if you're able to do that, you must. We can divide everything by 5. If I divide everything by 5, this will just be b to the 3rd. This one will be 2b to the 2nd. This one will just be b. And this one will be plus 2. Now we're going to divide the new one. I want you to notice that I'm going to have to put some spacers because I have a 3, 2, no 1, and no constant. So we're going to have, our coefficients are going to be 1, 2, 0, and 0. We set this one equal to 0 and subtract that to the other side, so we'll have negative 2. That's what we're putting here. Bring down our 1, multiply. We get negative 2 and 0. We could keep going, but since these are zeros and that's 0, we're just going to have zeros all along. But let's just show you. I'm going to multiply that. That'll be 0. Add, we'll get 0. Multiply, it's 0, and add 0. So we have this one thing. We started off with b to the third, and when we started out with b to the third, we went down to the second, so we have 1b to the second. We could say plus 0b to the, and 0, and so forth all the way down, but since we have all the zeros, we don't write them. And this is really, really important because we got a 0 for a remainder. So all we have is b squared. We're going to talk about what happens when we have 0 as a remainder in a little while. Let's do number 9. I want you to notice that all of them can be divided by 2. But I also want you to notice that we have an x cubed there and an x squared there, so it's not in order. So we're going to have to rearrange those. We're going to do that and divide by 2 at the same time. So we're going to put that one first and divide by 2, and it'll be x to the third. This one should be second. We're going to divide by 2. That's going to be negative 11x squared. This one's okay. We're going to divide the 42 by 2, and it's going to be 21. We're going to divide the 4, and it's going to be minus 2. Then we're going to divide the rest. We're going to divide. These are not in order either. This 2x should be in the front, and the 4 should be in the back. So let's rearrange that. We divide this, and we're going to get x. And we're going to divide that and get a negative 2. So my coefficients are going to be these ones in front here. It's going to be the 1, the 11, the 21, and the 2. Actually, the negative 11 and the negative 21. So we're going to go 1, negative 11, 21, and negative 2. And we're going to set this equal to 0, add the 2 to the other side, and we'll get a positive 2. Bring down the 1. We'll get a 2. Bring, and then add, we'll get negative 9. Multiply, we're going to get negative 18. Add, we're going to get 3. Multiply, we're going to get 6. And our add, we're going to get 4, and that's our remainder. Our quotient is right here with those coefficients. We started off at the third power, so we're going to go down by 1. So we're going to have x to the third, or 1x to the third, but I don't need to write the 1. Minus 9x squared. Sorry. We started off with the x here. We're going to go down by 1 to make it 2. We'll have x to the second. We could put the 1 in front, but we don't need to. Minus 9x plus 3. Now our remainder is that 4. It's going to be 4 over x minus 2. There's number 9. Let's do number 10. Can I divide everything by a number? Since I have this r right here, I really can't divide anything. So this is just how it is. Do I add any spacers? I have a 4th power, 3rd, 2nd, 1, and none. So 4, 3, 2, 1, none. Nope. Don't need to add any spacers. I'm just going to take the coefficients 8, 66, negative 51, 2, and negative 39, and put them inside 8, 66, negative 51, 22, and negative 39, and set that equal to 0. Subtract it over, and I'll have negative 9. Bring down the 8. Multiply, we get negative 72. Add, we get negative 6. Multiply, we get negative or positive 54. Add, we get 3. Multiply, we get negative 27. Add, we get negative 5. Multiply, we get positive 45. And then add, and we get 6. We're not finished. We have to write our answer. We started out with the 4th power, so we're going to go down to the 3rd. We start with that coefficient is 8. 8r to the 3rd minus this coefficient, 6r, go down 1, squared, plus 3r minus 5, and then we have a remainder of 6. over the r plus 9. And this is the answer. All right, a moment ago, we got a 0 as a remainder. What does that mean? That means that we have a factor. Let's talk about what that means. If you had 16 and you divided it by 4, 4 times 4 is 16, and I got a 0 for a remainder. That meant that 4 was a factor. So whenever you get a 0 for a remainder, it means it's a factor. And the factor theorem says that a binomial, x minus a, is a factor of a polynomial if you get a 0 for a remainder. We're not done factoring. We have another method we're going to do, but let's review what we've done so far. What we've seen so far is we have seen factoring by the box method. We've seen factor by grouping, and we've seen factoring with a formula of the sum and difference of cubes. There's still one more, and we're going to factor, and it doesn't have a particular name, but we're going to factor a non-quadratic as if it is a quadratic, but it has to be in a specific form. So let's look at that. We're going to do 17, 19, and 21. On number 17, this is in the form of a quadratic, but it's not a quadratic. Remember, a quadratic is something like x squared. And the quadratic form that we use the box method on is we have x squared like 2x plus like 3. This would be a quadratic that we could factor. If we couldn't factor, we could try the quadratic formula. But what makes this in the form to use the box method is we have a squared, and we have half of that exponent over here, and it's a trinomial. It's got 3 terms. This is in the same form. We have a 4, then half of that exponent is there, and it's a trinomial. So let's see if we can do the box method. But first, can we take something out of all 3 of these coefficients? Yes, we can. We can take a 3 out. So when we take a 3 out, we'll have m to the 4th plus 9m squared plus 8. And now we're going to use that box method to factor it the rest. We're going to keep our 3 there, but when we're done, we'll have 2 binomials. So we're going to do this m to the 4th plus 9m squared plus 8. What multiplies to be m to the 4th? We're going to do m squared and m squared, because in that quadratic form, these are going to have to be the same. Then we ask ourselves, what multiplies to be 8? We have 2 and 4 and 8 and 1, and we want them to add up or subtract to be 9, and it looks like that works right there, 8 and 1. So if I did 8 and 1 and I checked my diagonals, this diagonal is going to be 1m squared, and that's going to be 9m squared. So we'll have 8m squared and 1m squared, just to check that I am going to get my diagonal that I want. And yes, I am. So my answer, if you remember, is the horizontals. So I have m squared plus 8 and m squared plus 1. I cannot factor that any further. I am finished. Let's move on to number 19. Number 19, this is in the form that we'd like. It's got a 4th degree and then half of that there, and it's a trinomial. It's got 3 terms. So we can use the box method because I really can't take anything out of 3, 22, and 35. So let's do the box method. The 3x to the 4th could be 3x squared and x squared, but then I'm going to figure out what makes 35. We have 7 and 5 is the only thing that I know of except for 1 and 35. Let's try the 7 and 5 first. If I put the 7 here and the 5 here, when I do the diagonals here, I'm going to get 15x squared, and I'm going to get 7. x squared, and 15x squared plus 7x squared does equal to 22. So my check works, and that means I have the horizontals to do. And so I'm going to have 3x squared plus 7 and x squared plus 5. Let's now do number 21. Can I take anything out of these three? Yes. If you keep trying for a little while, you'll notice that 3 comes out of both of them, so all 3 of them. And if I take a 3 out of 48, I'm going to get 16. 168 divided by 3 is going to be 56. And 135 divided by 3 is going to be 45. Now I'm going to do the box method on this. I'm going to come over here and do 16m to the 4th. Let's see, I know I'm going to do m squared and m squared, so I can do 8 and 2, or I can do 4 and 4, or I can do 16 and 1. We're just going to have to pick one of them and test. And so, I don't know, I'm going to do the 4 and the 4 first. And I'm going to do 9 and 5, and so we're trying to get that 56. So if I do 9 down here and 5 here, and they're both going to have to be negative so that I can get that. And this is going to be 36, and that's going to be 20. So let's try 36 negative m squared and negative 20 m squared, and sure enough, that does make negative 56. So let's write that down. 3, 4m squared minus 5, and 4m squared minus 9. I need to look here. Do these, can I factor any of these again? I can do this one because this is a perfect square and that's a perfect square. This is called a difference of squares. So I'm going to rewrite the 3, 4m squared minus 5, and then I'm going to factor that one out because it's a difference of squares. It's the same as 2m minus 3 and 2m plus 3. So we're going to have to continue to think of our skills that we've used in the past. And we're finished with number 21. Let's review what we've learned. You learned how to divide polynomials. You learned what a remainder was. The remainder is helps you to find the solution, which is where it crosses the x-axis. If there is no remainder, then you know it crosses the x-axis there because it's a 0. You also found, and we also learned another technique for factoring the polynomial. I hope this has been helpful. Goodbye.